Good evening, everyone. Am I audible? All right. So, good evening. It's my pleasure to extend a warm welcome to all our participants on our last day of this 2 week short term training program on AI and ML coding using generative AI, powered by ISTEM, Indian Science, Technology and Engineering Facilitated now. This program is being conducted from March 24 to April 5th, and we are delighted to have you all on this exciting learning journey. Today we are going to an advanced machine learning techniques and facts using generative AI. So before we proceed further, please drop your name and affiliation in the chat box and use laptop for better learning experience, and make sure of that before you leave the session to fill up the feedback form, so which is only going to available in the chat box. So allow me to introduce our academia, InnovaWorld. Our academy InnovaWorld is dedicated to fostering interdisciplinary learning and research through advanced training program, workshops and industry collaborations. Our mission is to bridge the gap between theoretical knowledge and the practical implementations, empowering the learners to excel in emerging technologies in different domains. I extend a heartfelt welcome to our esteemed guest for this entire week, Dr. Arunava Majumdar. We are grateful for his presence and looking further for his valuable insights, and he takes over in today's session. Wishing all the participants a very exciting and great learning experience. And once again, I welcome Dr. Arunava Majumdar, sir. So please take over the session. Please, sir.
Yeah, good evening, everybody. Thank you for the introduction. And it's the last day of the session, and we have explained and we have gathered many knowledge about the machine learnings, different kind of statistical models, statistical approaches. Okay, and whatever the basic things in AI and ML and machine learning, and basically the main task is the how you can generate the code from generative AI, and how generative AI can automatically can also perform whatever the task you want, and can also gives the result, but only one problem, because due to means if you are not having the subscription, then you have a limited access of it. Okay, however, the code can be generated by it, and you can use the code in your own platform. So we have learned both regression and classification so far, and in regression and classification, in both cases we have done the static what are the basic statistical approaches are, and like linear regression, multilinear regression, okay, non-linear regression, and also in case of classification, logistic regression we have done. And the AI sorry ML methods like decision tree and random forest also we have learned, and random forest and decision tree in both for classifier and both as a regressor we also have done some examples from that. Okay, and the matrices, what how can you check the accuracy of your model? Many matrices are there in regression. We have learned what are the matrices, also we have learned in classification model what are the matrices, also we have learned. Okay, so the matrices which are remaining today in classification model, so we will explain today first of all, and then I will go for the example of some higher level ML algorithms like XGBoost, that is extreme gradient boosting, and the cat boost, which is called the categorical boosting. And we will also verify that XGBoost and cat boost, how they can improve the performance of the model. So let's first we start with the metrics which is remaining, which is the curve, that is AUC, and AUC value, that is area under the curve. AUC means a simple area under the curve. Basically, we are talking about the ROC curve. Okay, so what ROC is? It is called the receiver operating characteristic. Okay, receiver operating characteristic, and ROC curve, receiver operating characteristic curve. And AUC means area under this ROC curve is called the AUC. AUC general meaning is area under the curve. Now whose area? The ROC area under this ROC curve is called the AUC. Okay, so the method of finding the AUC and ROC, basically we need to find out the X values, that is a false positive rate, which is the X values, and the true positive rate, TPR, also called the recall, which is on the Y values. And then we plot these values in a graphical plane and the graph is created. Okay, so ROC, let me first share my screen. Okay, first we need to learn this one. The ROC curve shows how well your model separates the positive and negative classes. Okay, so how it separates the positive and negative classes, that is called the ROC. It shows, and what is the values of x-axis? The values of x, it is defined as or can be calculated like this: false positive divided by false positive plus true negatives. And how we can find the values of false positives and true negatives? We can find the values of in this confusion matrix. So confusion matrix can so this is, you can see, this is 0 0, it means a false negative, 0 1 false positive, 1 1 true positive, 1 0 false negative, sorry, true negative. Okay, so these are the values. We can find all the values from here in this matrix only, and after finding the values we will put it into this formula, FPR and TPR, and then we will plot the graph. That is, we see that x-axis. Oh, okay, okay. Now it's visible. Okay. So what I was telling, ki ROC curve. Okay, it actually shows how your model separates the positive and negative classes. Okay, positive class means one and negative means zero classes. Okay, how it separates. So we to do this we need to find out the value of FPR and TPR. What is FPR? False positive rate. TPR means true positive rate, and this is the formula: false positives divided by false positive plus true negatives. Okay, and how can you find these values of false positive and true negative? By using this matrix, that is confusion matrix. Okay, so this is 0 0, it means it is false negative, 0 ones false positive, 1 0 true negative, 1 1 true positive. So by using this matrix, we can get the values from here, and we will put the values in this formula, this one and this one. And then you see that FPR means it is the values of the x-axis, and TPR values on the y-axis, and we will plot a graph like this. Okay, a graph is plotted, and then the baseline, that is, which is here, this is called the mean line or baseline. How your graph it deviates from the baseline. That is how the area under this curve, if your area is greater, then we can say that yes, model is also better. If the area is less, then we will say that model is not that much better, okay, comparatively less. Okay, so this is called the AUC. So AUC means this, I am talking about the area, and ROC means the receiver operating characteristic. This curve is called, what is the curve is generated? This curve is called receiver operating characteristic curve. Okay, ROC. Now let's go to the program and that one GPT, and let us generate a curve. First of all, okay, let me go to the GPT now. GPT or DeepSeek, you can use any one of them. Let's go to DeepSeek today. Okay, and I use the same program which I used in the last class for the classification problem. Okay, so this is the problem, that is, okay, let me divide this one first. Okay, so this is our program which we were already have done in the last class. And first of all, let me uh, run the program first. Our program, it is a heart data set, that is heart disease. If it is 0, then no heart disease. If the outcome is 1, then it is a heart disease. Now this model basically predicts the confusion matrix we have drawn here, and along with the confusion matrix we have done different ML techniques. That is, here you can see three classification report we have generated. First classification report is for logistic regression, and which is accuracy 0.842 and F1 score 0.857, and decision tree 0.739 and 810 F1 score. And the third one is random forest 891 and 906. And we saw that the random forest gives us the best result, that is 0.891 and 906. Okay, so we need to suppose now we need to also calculate the AUC, and also want to draw the ROC curve. Okay, so how can I do this? Now this one already we have generated this particular coding, or we have written this particular coding. We need to first copy this code. Okay, we copy the entire code first, and let me paste it in the DeepSeek. Okay, as a layman, I don't know anything, so it means that I need to add something here. Okay, so now I just need to write here, add ROC curve for each algorithms, or each algorithm. Okay, now it's done. So let me see what it generates. Okay, all the other things are okay. Okay, it sets up the figure for ROC curve here. You can see. Okay, one thing, two things you can do. One thing, you can totally copy and paste this code in your means platform. Or secondly, you can do what are the modifications it has done. Okay, what are the modifications it has done, and accordingly you just copy and paste that particular modifications in your code. Okay, you can do both of the things. If you are a layman, then I, of course, I will suggest that just copy this code entirely, and you can just paste this code in your coding platform, and that's all. Okay, so without any delay, I will do this one only. Okay, that will save your time also, because rest of the other things are okay. Okay, one thing you can see here, you can see scalar matrices import accuracy score. This was already written here, and what are the extra things we need to import here? ROC curve, AUC, and ROC curve display. Okay, so from scalar matrices, it again writes the same thing. So without writing the same thing, you can just copy this one and paste it here only in the previous code. That also it's right. Okay, that also runs. Now I think there is no other extra challenges are there. Let me run the code now. Yeah. Okay. Look at this one. This is the ROC curve, what it generates, but I don't like this curve because uh, nothing is written here. So it generates each and everything. Means for confusion matrix for random forest, then it is generates the ROC curve for random forest, but it doesn't generate it separately. Okay, so this is the ROC curve. Okay, comparison for random forest. Okay, so it means that it generates, but it generates something means which I don't like or don't want. Okay, so how can you modify it? So again, you need to use the prompt such that you can modify this one, modify the code above, and here you can just write modify the code with. Okay, now it has done something. Let me check that. Yes, now it generates separately. Now look at this. This is the ROC for logistic regression. Okay, what is the value of AUC? Look at this. The value is 0.90. Okay. Now let's go for the second one. This is the confusion matrix plot for decision tree, and it is very less. You can see the ROC value, the AUC value. It is 0.80, which is much less than the previous one. Okay. Now go to the third one. Yes, look at this 0.94 random forest. So it means it clearly says that random forest, it gives us the best ROC value, and that is why we can say that random forest gives us the best prediction here. Okay, so this is your conclusion. Now I'm going to show in this case the ROC AUC curve. This is, you can also add this curve along with the confusion matrix and along with the classification report. Okay. Now another matrix is there. Now this is all for the classification only, classification problem. Now in regression there is another thing what we have to display, that is called the scatter plot, which for the predicted values and for the um, that is actual values. So scatter plot for predicted and actual values, that is remaining. So that thing also you need to test it. Okay, so let me, for that one, let me go for the previous one, that is another data set. The data set is for the which is the share market data set. Okay, and target is the volatility. In this data set, I already explained that data set in the last class, that is yesterday's class. So I'm using this data set now, which is a stock market data set, and in this data set volatility is our target, and which is having some continuous data. Okay, and I know that in continuous data we have to apply the regression, and let's first run the regression. This is the correlation heat map. Yes. So after this regression, we see that our values, we have three values here: linear regression, decision tree, and random forest. And all the cases we see that the R square score, it is negative for decision tree and random forest, only positive, still very less, near equal to zero in linear regression. Okay, so among our linear regression, decision tree, and random forest, linear regression gives us somehow better result, but not good at all. The model is not fitted, but comparatively better than the others. Okay, so in this case, let me, now what are the things we can draw here? Means we can show as a plotting. We can show the plotting for the regression line plotting in linear regression for the predicted value and the that is original value. Okay, so let me explain what this value is first. So you can see, let us suppose x1, x2, and x3, these three are independent columns, and y is the dependent column. So now let's suppose 0, 1, 3, and so on. These are the data, and our y data is, and so on. Okay, we need to now a model is created based on any one of the either linear regression or decision tree or random forest. By using any of the algorithms, a model is created and it predicts the data. So what is the first value? First independent value is 0, 1, 3. So for 0, 1, 3, if I pass 0, 1, 3 in our model, we, let us suppose that we are getting it is 2.3 or something, let us suppose. Okay, second data 3, 1, 1, suppose that we are getting 11.5. The third data is 231, and which is the 7, let us suppose, and fourth data is 517. And if we pass 514, 514, if I pass this data in our model, we can, let us suppose that we are getting 6.3, and like this. Okay, now we will plot. Okay, that is y original and y predicted in this plotting. So y original and y predicted, the first point is y predicted. So what is the y original? First point of y original is 3. So 3 means 1, 2, 3 here. And y predicted is 2.3. So 2.3 is 1, 2, 2.3. Let us suppose it is here. Okay. So the point will be this. This is the first point. 3, comma 2.3. Okay, the second point is 10 11.5. So level 10 11.5 is somehow here. 9 7 9 7 somehow here. 7 6.3 7 6.3, suppose here. Okay, and 7 6.3 is nice. Here 7 6.3, and the other points suppose here here, okay, like this. Okay, so we need to check that whether this line, the trend of this line, if I draw a straight line, the R square value should be very high here. The MAC, the RMAC, all these values will gives you a very nice prediction, that is nice modeling here. So if I plot the points, predicted and original values, as a scatter plot, okay, and we draw a regression line, linear regression, simple linear regression, then this linear regression line, okay, it should be fits uh, very, as a very high, with a very high accuracy. Only then we can say that yes, this model is very good fitted model. Okay, its MAC and RMAC should be very less, its R square value should be very near equal to 1. Okay, so now let me check that if this model, okay, so in this case I already have checked that this model is not fits base case, means it is a not a better model at all. Okay, so still we need to draw the scatter plot, and for the predicted and original values, and let me first copy and paste it, and let me check that how this model uh, actually works. Let me first copy and paste the code, whatever I have written, and lastly, okay, and I will write that add predicted versus original plot with R square, MAC, and RMSC values. Okay, add predicted versus original plot with R square and these values for each model. Okay, so now it modifies the model by adding this. Yes, let me copy this one. Yes. First correlation matrix. Yes, look at this. Now this is the original linear regression. This is the predicted versus original linear regression. Look at the points. The points are not at all like this. I told you the points should be like this. Okay, in an upper trend. The point should be as an upper trend. Okay, like this means one value, that these values y prediction and y uh, predicted and original y should be very closer to each other. If they are closer to each other, then only we can see an upside trend of these points. But look at the points here. This points is not at all is giving us an upside trend. It is exactly, it is scattered as a means uh, it means parallel to the y-axis. There is actual volatility, and you can see that this not at all giving us. They look at the r square value 0.003, MAC 0.00, RMS is 0.12. So it's not at all give us a good model. So that is why all the our values are so much means means a bad prediction it is giving. Okay, so look at for the second one, decision tree. So decision tree is also, you can see the points are entirely scattered. The MAC is giving us a zero MAC. Okay, but you can see the RMAC is low, but you can see the R square value is not at all a good things. So the points here is entirely scattered point. It is not at all giving us a good prediction here. Third one, random forest. Also, it shows that however the MAC is zero, but the R square value is negative here, and the points are scattered. Just it is like almost parallel to the y-axis. Okay, and this is the baseline. You can see the red line. It is the baseline. It not the baseline is at all not at all matches with the scatter plotting here. So we can see that these models are not at all give you a good prediction. Okay, now I'm going today the advanced part of the ML modeling, XGBoost and CATBoost. Okay, so let me first share what XGBoost actually means. Okay, I'm sharing my screen now. Is my screen visible? Okay. So basically, XGBoost, it's an ensemble technique that builds the models. Now, what XGBoost is, I already have explained decision trees. Okay, so XGBoost, it uses decision tree as a base learner. Okay, and it then what it does, it then it corrects the value which is made by the previous value is corrected. And how it is corrected? Gradient, by using this gradient technique. And this is the means actually the optimization technique is used here. So what optimization technique is? Optimization, I'm not going to It's a very vast area in mathematics and means in statistics, basically in mathematics. So any function, let us suppose that something that may be any kind of function, let us suppose we are trying to minimize time, we are trying to minimize distance. Okay, so a technique which can be minimized or maximize something means some function. This function may be a function of time, maybe a function of distance, maybe a function of cost. Okay, either we want to minimize this or we want to maximize this. So here what we want to actually minimize, we want to minimize the original minus predicted. Okay, so this value, okay, so if these values, basically original and predicted, there are different values of their y original and y predicted. So these values we are going to minimize the error, original and predicted, original value and predicted value. Okay, the difference between original and predicted, this gives the error, right or not? So if we want to improve our prediction, of course we need to minimize this. Okay, we need to minimize this particular error. So this minimization method actually, it this object, this is treated as objective function. This one, this should be treated as an objective function, and this objective function is minimized here in this case. Okay, so I'm not going to give you much better mathematical explanation here. It is not required at all for a layman. So gradient boosting, what we are doing, it uses a base model, the tree model as a base model. So what is tree model? Tree model is a decision tree. Okay, so it uses decision tree as a base learner. First is uses this, then the loss function. Okay, both so it is objective function I have used here. So both loss function and regularization. What is loss function? Mean squared error. So mean squared error means this one, means the y, that is a mod of, it is not mod, it is norm. If the value is single value, then it should be used as mod. Basically mean squared error. So mean squared error, it is give you the, like means it should be a square. Okay, mean squared error is the original, the squared value, means original minus the predicted, and we square these values, original minus predicted, and we square this value, and then we minimize this one. Okay, so it also minimize these values, this mean squared and regularization, both are simultaneously we are doing in this XGBoost. And what is regularization? Regularization to avoid the overfitting. Okay, so it's no time to discuss about what is underfitting, what is overfitting. I'm not going to discuss here. I suggest you to read all these things. There are too many things are there, which due to the lack of time I can't means explain all these things. Okay, so this is not only a tree model. With tree model, we are merging something. Means we are doing something, some algorithms, extra algorithms. We are giving some extra effort to minimize the error. That is to strengthen our model. Okay, so this is called gradient boosting technique. So it's an ensemble technique that builds the model sequentially. Okay, so it corrects the previous error again and again. So, and another thing is CAD boosting. Let me first use the XG boost and let me try whether the model prediction somehow it is better or not. Okay. So again, I am going to the GPT. Now I type here, add, sorry, Extreme gradient boosting. Yes, XGBoost, the full form is extreme gradient boosting. XGBoost. Okay. So XGBoost, in this case, we need to import because this model is a regression model. So we need to import XGBoost regressor. Okay, here. And the model is modified now. Linear regression, yes, all the things are added. Let me copy and paste simply because otherwise I need to modify everything one by one. So let me try this one now. It may, I'm not saying that always it will give you the best result. Okay, it may give you the best result, may not be. Okay, let's see that. Is this is linear regression, the previous result. Decision tree, somehow it is improved somehow, but not more than that. Random forest, XGBoost. Look at this, r square value, so minus 0.1 MSc or MSc 0.13. Okay, let me here. Okay, not that much modified because according to the data set it cannot be modified further. Okay, but the r square value, if you see here, uh, decision tree, it is giving you the r square value as a worst r square value minus 0.6 is the highest, means lowest r square value, and not possible at all, means decision tree should be anyhow it is rejected in this case. And in other cases you can see that r square value here, uh, 0.11, yes, linear regression, XGBoost, decision, random forest. These three things are giving, gives you the MA value 0.011, almost same. R square value still it is best for linear regression, and XGBoost it is not that much good here also. Okay, so still linear regression wins in this case, but still all the this is not acceptable at all, not all values, because the data set you can see we see now that whatever the algo we are applying, or how much means the things we apply means how much we also modification we have done, still the results is not at all, we are getting the good result. So in this case, what we can do, we can either include more data sets in your data set, because in this data set, you, if you remember, we have means dropped some of the columns here. Okay, so if you have to add all these columns which has been dropped already, okay, here in this data set, and also we need to check that whether there is any missing values or not. If there is any missing value, we need to means modify, means we need to impute the missing values here. Okay, however, decision tree and these tree based algorithms, they can handle the missing values by itself. Okay, and sorry, outliers, missing values, if you have any missing values is there, yes, they can also handle sometimes. Okay, um, now we're going to the CAD boost. Okay, CAD boost, use, add CAD boost. Okay, one thing you should remember, if the cat boost this package sometimes it is not installed. You need to install these packages by using pip install cat boost like this, pip install xgboost like this. Okay, otherwise your code may not run. Okay, let me copy and paste it and let me see that whether it improves or not. I don't think that that much improvement will be there, because the dataset itself is not good dataset. We need to modify the dataset itself. Linear regression, decision tree, random forest, XGBoost, cat boost. Okay, is it modified? Let me check this one. So cat boost, look at this. So this is your classification result. Sorry, regression result today. 0.003. Yes, in cat boost you can see that yes, it modified now. The cat boost is giving you the highest result, best result now. R square value also modified from negative, it now turns into positive 0.019. Okay, which is much more better than the R square value for linear regression also. Okay, and 0.001. Okay, here MA is also same 0.001, no changes there, but R square value is improved a lot. Okay, so you can use this R square value here, means cat boost result here. Okay, to means show that means your means improve your model. Okay, so here in this case cat boost wins, so cat boost gives you the best result here. Okay, the categorical boosting. So basically, the symmetric tree is it used in cat boost. Okay, and it is the modified features which is used in the XGBoost. Okay, so another there are many other methods you can use. Now, are yes, another things which is remaining, ANN. Okay, the neural network, that is the artificial neural network. There are two kinds of neural network: artificial neural network and convolutional neural network. ANN is generally used when this kind of data sets means uh, the we are going to have this kind of means we are having the data sets of like uh, where any classification problem like heart disease, single classification, binary classification, or we are some problem of this market dataset problem. Then ANN regressor is also there, ANN classifier is also there. You can use it, but CNN it is used for the image problem. Okay, any kind of image processing type of problem we will use there. I'm not going to much discuss about it. There are a lot of things we need to discuss then. Okay, so because of the lack of time, whatever the discussion is necessary, whatever the things necessary, I have already explained, means almost cover all of that things, all the basic things, all over whatever we have learned here, all are basics, and somehow it is advanced, means a little bit advanced level we have also learned here. Okay, and let me now go for the some other techniques are also there. Let me just discuss about it, but I'm not going to generate the code for them. um, the other algorithms which is required here, you can also use the support vector machine. It is called SVM. Okay, ANN, artificial neural network, CNN, convolutional neural network. Okay, also there are other techniques are also there. I'm not right now, I'm not going to discuss all of these things, but these three things you can generate the code. I'm not talking about the CNN, but support vector machine and ANN. You can generate the code from the GPT or DeepSeek, and you can use it in your platform also. Okay, so this is all for today. Anybody is having any question, any kind of doubt, whatever we learned till today, you can ask.
All right. Thank you so much, sir. And before winding up the session, I request all the participants. So, you know, the feedback link is very, very important. And today you will have, please kindly fill up the feedback link. You know that this feedback link will help you to get connected with your certificate, which will be directly provided from ISTEM, right? So requesting all the participants, whenever you will have those feedback link, so please kindly fill up the feedback link, and also requested to provide the any suggestions for the event, write down in the chat box. If you have any suggestions about the event, if you like this event, requesting all to put your feedback in the chat box. And if you have any questions, so we can take those questions. So we have some questions in the chat box. What is this all SVM and ANN? What we are gonna study about this?
Okay. So this is ANN is called the artificial neural network. Okay, both you can, just like the XGBoost, just like the means decision tree and the random forest algorithms. These are different kind of algorithms to predict some or to prediction for the prediction purpose, right? So there are two kinds of, I already told you that two kinds of things are there. One is regression and another one is classification. Okay, if your prediction variable or the target variable is continuous type of dataset, then you use the regression. If it is means that type of means categorical type of dataset, whether it is binary category or trinary, means three categories or four categories, use classification. So as we have seen that both cases means classification and regression, the decision tree is applicable for classification and regression both purpose. The random forest is also applicable for classification and regression. So ANN or neural network, support vector machine, all these things can also applicable for the prediction of ANN and sorry, this classification and regression. Okay, so in that case, what you means, these are the different models, just like random forest and other things. These are the different models. Okay, you need to use different um, library in the Python, and you need to import this library here, and then import the library, and from that library you need to import the proper function here in this. Sometimes you also need to install the functions also in ANN. You need to install some functions maybe. Okay, if it is not installed in your computer, then you need to install them. Similarly SVM also. Okay, sometimes you need to install, sometimes it is already inbuilt. Okay, so these are the different types of algorithms, different types of prediction method. Okay, you have to apply all the algorithms, and you need to check that which is giving you the best result, and that algorithm has to be taken as a means best algorithm for your model, for your dataset. Only for your dataset this particular model works the best.
Right, sir.
Are you getting my point?
Yes, actually, meanwhile, there was another connecting question that out of this three model nowadays, which one is the most focused? And I think you have clarified the answer. Do you like to
Yeah.
clarify some more, sir?
Based model, we can't say that this one is the best model or that one is the best model. Everything depends on your dataset. Okay, so how you have managed your dataset, how means how you have imputed your dataset, by using what kind of algorithm you use to data imputation, for the data imputation, and whether you have used any dimension reduction or not, whether you have used any kind of outlier reduction or not, okay, in your data set, and whether your data set is linear or non-linear, how much non-linearity is there. Okay, all this it depends on all these things, which algorithm is giving you the best result. Yes, of course, we will say that cat boost, sometimes cat boost is having a very powerful algorithm. It gives you the better result than others many times. Okay, for but if you use some ensemble by using whatever the algorithm you have used, if you gathered all the algorithms, use an ensemble. Okay, I didn't explain here ensemble. Okay, because that is very high level things, so we don't have that much time to explain that one. So that things may give you sometimes best result. Okay, if you use the ensemble, that is combining all the algorithms.
Okay. Thank you, sir. And one more information for all the audience and the participants. So make sure of that your certificate you'll be getting within a week, and make sure of that when you're typing the feedback form, make sure you write the correct email ID or the contact, and also your affiliation, whatever the affiliation that you're going to register in this feedback form, the same uh, affiliation will be added on your certificate, right? So in during this once you receive the certificate, if you have any issues, please do contact our contact hub, that is contact at academyinnovaworld.org. So I hope in this complete session you have learned a lot. At least you have, if you are this session was only meant for the ground level to understand what is machine learning, and how you can use, especially this course is developed for non-computer science background. If you are a non-computer science background and still you need to implement machine learning in your research work, or maybe you are a scholar, how you can get into it and work and develop a very good model, and predict the model and proceed further and publish it. So I hope it is 2 weeks. You in this 2 weeks you have learned a lot, and I'm hoping that you have definitely take away a lot of things. And you will be receiving a mail. In that mail, you will be also getting the code, whatever the sir have done, because many of you have requested. So we will be giving you the sample code and also sample lecture, whatever sir has done, and along with this a playlist, all our recorded session. So all these things we'll be receiving during this mail along with your certificate. So hope you have a pleasant journey with us, and looking further to collaborate with you and work further with you. Thank you so much. Thank you everyone, and hope to collaborate furthermore in our furthermore events. Thank you so much. Good night everyone. Take care. Thank you so much, sir. Thank you, Arunava sir, for your valuable time for this entire week. And thank you for supporting Academy in our world. Thank you, everyone. Good night.